Hello and welcome to my channel. So today let's look at the Leetcode 725 split linked list in parts. It is also today's Leetcode daily challenge. So the question is, given the head of a single linked list and an integer k, split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible, so no two parts should have a size differing by more than one. This may lead to some parts being null. The parts should be in the order of occurrence in the input list, and parts occurring earlier should always have size greater than or equal to parts occurring later. Return an array of the k parts. So the example is firstly 1, 2, 3, then k is 5, and so the answer is given an array of length 5, which is the first three elements is the node 1, 2, and 3. So the last two is null because we already used all the elements in the first three. So the second example is 1, 2, 3, 4, 5 to until 10, and then k is 3. So the last two elements in the array is with 3 nodes, but the first one is with 4 nodes. Yeah, so let's see the constraint. The number of nodes in the list is in the range 0 to 1000. And node value is between 0 and 1000, and the k is between 1 and 50. So the question is, we firstly we don't the input is a linked list. So actually we don't know like how many. Firstly, we need to get the n, which is the number of nodes in the list. That's after we getting the so to get the number of nodes in the list, it's easy. We just iterate the list from the first one until the last one, and we increment a counter so we can get an n. Then the secondly is we need to split it into parts. So the number of parts is already given, which is k. So we need to k parts. If we know like how many nodes will be in each part, then it's quite straightforward to solve. So if n is if n is divided by can be divided by k, then there will be n divided by k nodes in each part. But if n is n mod k is not 0, then we need to put those mod into the first few list elements. So here we can use the examples from 1 to. So assume we are given this list. So here n is 10. So n divided by k is 3. And n divided by k equal to 3. So n mod k is actually 1. So what we need to do is we can split nodes into k segments. Each segment has 3 nodes. Like has actually here we has n divided by k nodes. But for the first n mod k segments, we need there is one additional node. Or we can say assign one additional node. So in this example is firstly it's 10, so the n divided by k is 3. So we actually we can divide it by we can firstly get 3 nodes put in the first first segment, but because the mod is not 0, it's 1. So in the first segment we need to assign one more, so which is 4. Then in the second and the third segments, we just assign n divided by k nodes. So also there is a special case. We need to make sure the special case is covered. Like if n is smaller than k. So if n is smaller than k, n divided by k is 0. So actually, either n divided by k is n mod k is n. N divided by k is 0. So it's actually still covering because so we actually have the first segment is 0, but we need to assign one more node. So first n segments we need to assign one node, but after that it's 0 node, which is now. So also the second special case is because n here is the number of nodes in the list can be 0. So n can be 0. If n is 0, so n divided by k is still 0, and n mod k is also 0. So that actually still is covered in this by this approach, because we will have a 0 length in each segment, and also we don't assign more nodes in each segment because the mod value is 0. So yeah, so it seems it's both covered. So okay, now let's start coding. So firstly, we want to define a dummy node to point to the head. So dummy d. So we will point to the current head, and then we need to get in the n. So we if n head is not null, then we point to the head next. So when the head is so we actually count how many nodes in the in the list. Then next we can get the length of the segment n divided by k, and also get mod n more k. Then we can start. First, we want to have I equal to 0, which is a variable to increment. And also we want to define the answer array. So the answer array have a k elements. So while I smaller than k, in each iteration we take care of one segment. Now we can need to we also need to define a pre-node. So to point to the previous of the current node. So list node pre we define as a dummy, and the list node head we point back head to the original head. Okay, so now we can just start incrementing the we define another variable called j. So if j is smaller than length, so answer I equal to head. So after we define the head, assign this head to the answer to the ith element in the answer array. We need to find where is the end of the segment. Then also we need to assign the null to the next of last node, and also we need to initialize put a head in this location, which we can start to get in the next iteration to get the next segment. So yeah, so now we can do head to be head next, and we do it length len times, so that we will point to the. So then if the I is smaller than mod, which means we need to update pre. So we need one more in this case. Yeah, then we can actually assign next of pre to null, and the head will be the starting node of the next segment. And in the end, we just return answer. So let's have a look at if everything is covered. Yeah, okay. Let me run the 2 examples in the question. Okay, so both are correct. So let's submit. Okay, it got accepted. So the time complexity is Time complexity is O(n), because we just iterated through the list twice. First time we got n, and the second time we split two segments. The space complexity is O(1). So let's conclude today's challenge. So if you have a question, please comment in the video. And so if you like it, please click like button or subscribe. And so thank you for watching. See you next time.